Okay, so today I am covering exponents and square roots. I'm putting them together because they are related. They're the one's basically undoing the other thing. And this is where a lot of people tend to make errors with their math. So it's an important thing to make sure you get clear, especially because later in the term, we're going to be doing a lot more work with exponents and square roots. And so you will see this again. So this is just one topic out of many topics that you are learning this week. So I can't cover everything in an hour. So I just pick something that I know people tend to need some extra help on. So exponents, what are exponents? So an exponent is how we represent repeated multiplication. It's a shortcut to writing a whole bunch of things multiplied by itself lots of times. So you don't have to keep writing it, like you don't have to do 2 times 2 times 2 times 2 times 2, and like so on. You can use an exponent and it takes up a lot less space. So the mathematical theorem or the definition, you have B. So B just represents a number. And then N is positive integer. So that means that there's not going to be any decimals. There's not going to be any fractions in your exponent. We're just having positive exponents here, but what's underneath the exponent can be anything. So the number up above the main thing, the N, that is a superscript. If you're trying to figure out how you type that in like Word or something, it's called a superscript because it's up above. And so that is telling you how many times the number underneath is multiplied. So if it's B to the N, you have B multiplied by itself N times, and these are called factors. So the numbers that are multiplied together are called factors. So N, the exponent N, is how many times it shows up and is multiplied. And then the number underneath it, we call the base. That's why we use the letter B. That is what is actually being multiplied. So we'll read B to the N or B to the nth power. Certain exponents have a specific way to say it. Like if it's a 2, we say squared, or a 3, we say cubed. Otherwise, we just say to some power. Power and exponent are used interchangeably. They mean basically the same thing. Now, whenever you have an exponent and your base is negative, we always put that number in parentheses. So if you have like -2, -2 would be in parentheses and then whatever the exponent is. If you don't have the parentheses, that negative is not part of the exponent. The exponent is only attached to the number it's directly underneath. So that negative is really acting as a -1 being multiplied by the exponent part. So it's really important to know the difference between those and what the exponent is attached to and what it's not attached to. So we're just going to practice the notation so you can get used to writing repeated multiplication as an exponent, and so you can see how this is created. So we'll just start from the top row and move left to right. So it says write each product. Product means multiplication using exponents. So we have 10 times 10 times 10 times 10 times 10 times 10. The number being multiplied is the number underneath the exponent. The exponent is how many tens you have here. So we have 6 tens. So this would be 10 to the 6th power. So we have 10 and it's multiplied 6 times. Next, we have 1/6 times 1/6 times 1/6 times 1/6. So you can have exponents on fractions. When we have fractions, we usually put the fraction in parentheses so that it does not look like the exponent is on the 1 only. So if I just put the exponent without parentheses, it might look like it's just attached to the 1 that's there. So We put parentheses around the fraction to indicate that whole thing. And then we've got 4 of them. So that is going to be to the 4th power. So you have parentheses around the 1/6, and then that is to the exponent of 4. Next, we have -2 times -2 times -2 times -2 times -2. So -2 is the thing that's being repeatedly multiplied. And we put that in parentheses because that's getting the exponent. That whole -2 is getting the exponent. And there's 5 of them. So that's going to be -2 in parentheses to the 5th power. Bottom row, we're throwing in variables. So we're throwing in letters, and the rules still apply. You just kind of group them together. So we have the first one, we have 7 times x times x times y times y. So 7 is not multiplied by more than 1 7. So it just stays the way that it is. The x, we have 2 x's multiplied together. So we can write that as an exponent. There's 2 of them. So it's the base is x. And then the exponent is 2 because we have 2 x's that are multiplied together. Then we've got y times y. So we have 2 y's multiplied together. So the base is y, and those also have an exponent of 2. So we would write this as 7x squared y squared. And so with multiplication with numbers and variables, when we put them together, we generally don't put the multiplication symbol between them because they're different objects. It's assumed to be multiplication. And so you just kind of put them all together. And with our exponents, we need to group things that are the same, that are getting multiplied.
I have a question, Professor.
Go ahead.
This is Nate here. So I'm back when I was having to fiddle around with my microphone. When I emailed you about the question, it said -4 squared. How do the parentheses play and not play on, like, your example of the -2 to the 5th power?
So that is actually going to be covered in the next slide where we're going the other way around.
Okay. All right, I'll
yes.
find them.
So yeah, so that is different from what we are currently doing.
Okay.
Are there questions on what we're currently doing? Okay. So the next example I have is 5c times 5c times 5c. So the thing that's being multiplied multiple times here is the 5c. And so since it's the 5 and the c are together, to indicate that those both are being repeatedly multiplied, we need to put those in parentheses. So we have to indicate the whole thing 5c is in parentheses. If we don't, then we're saying that, and we put our exponent on it, it would look like the exponent's only on the c, but we want to include the 5 as well, because that whole thing is getting exponents. So there's 3 of them. We're multiplying 5c 3 times. So that exponent would be 3. So you have it in parentheses, 5c to the 3rd. Now, to the right, the last one we have here, we have -3 times w times z times z times z times z. So our -3 is not being multiplied by another -3. So it's just going to stay as a -3. We don't have w multiplied by another w or anything. So that's going to stay as w. And then we've got z multiplied by z multiple times, and there are 4 z's there. So we're going to put a z with a 4. So that exponent of the 4 because we do not have parentheses, that exponent is only attached to the z. It is not part of the w. It is not part of the -3. It's only on the z. So you put parentheses around if you have multiple things that are having that exponent, or if you want the negative included. Otherwise, we don't have parentheses because the exponent's only attached to what is directly underneath it. Are there questions on these examples? Okay. So now we're going the other way. We're going to write each expression in expanded form. So that means instead of keeping it as an exponent, you're going to write it as the repeated multiplication. So we're using the definition of the exponent to do this. So we start with y to the 4th. So that means that we have y multiplied 4 times. So that's going to be y times y times y times y. So I have 4 of them multiplied together. So that is expanding out that exponent. Next, we have in parentheses 8c squared. So because it's in parentheses, that 8c is taken together. So there's going to be 2 8c's multiplied together. So that's 8c times 8c. So they're grouped together. Next, we have 10y to the 5th. So there's no parentheses. So that 5, that exponent of 5 is not with the 10. It's only on the y. So when we expand this out, we have 10, and then we have y written 5 times. So the 10 is not part of that because that is not in parentheses. So that's going to be 10y times y times y times y times y. Or you can even put I can put another multiplication there, 10 times, and then those 5 y's. When we look at the second row here, we've got x squared y cubed. So the x has an exponent of 2, which means the x is multiplied 2 times. So that's going to be x times x. And then we have the y with an exponent of 3, which means we have y multiplied 3 times. And these are all multiplied together. So it's going to be times y times y times y. Next, we have in parentheses -10 squared. So it's in parentheses, so that negative is part of the exponent. So this is telling us we're doing -10 times -10 because it's squared. On the right, we have a -6 cubed. So the negative is not in parentheses. So that negative is not part of the exponent. That negative is really, that's that -6 cubed is like, that's like a -1 times 6 cubed because only that 6 has the exponent. The negative is not part of it. So we have a negative, and then we have 6 times 6 times 6 because that exponent of 3 is only on the 6. It's not on the exponent. So that's separate. That negative is getting multiplied by the 6 times 6 times 6, which you can think of as a -1 times 6 times 6 times 6. So this is answering your question, Nate, where if the negative is not in parentheses, it's not getting the exponent because the exponent is only on things that it's attached to, or if it's attached to things in parentheses, then everything in parentheses is part of that exponent. So if there's no parentheses, it's only attached to what it is directly on. So that negative for that is included when it's in parentheses. It's not included when it's not in parentheses.
Okay, I think I got it.
Other questions? Okay. So now we're going to get to the next step. So it says simplify each expression. So the word simplify means that you are actually going to try to do the math, essentially. So in addition to actually writing out what we're doing here, we're actually going to do the multiplication. We're actually going to get an answer here. An expression means that we have things without an equal sign. So that's what we're doing here is we're going to get an actual answer for what these are rather than just writing it out as repeated multiplication or the other way around. So we start with 5 cubed. So that is 5 times 5 times 5. And that doesn't want to write. Let's try this again. Here we go. So when we're multiplying this, you can do this all on your calculator at once. Like if you have a calculator, you can just take it and do 5 times 5 times 5. You can do 5 3 times. And that gives us 125. So that would be, when you simplify, that would be your answer, 125. That is what that is equal to. But you really want to learn how to use your calculator to do exponents, because once you get higher exponents, you're not going to want to sit there and multiply and then make sure you actually have the correct number multiplied. So everyone's calculator is different. My calculator, and this is the calculator that I recommend, has a button that looks like that. And that is a button that represents exponent. And so if I was to do 5 to the 3rd power, I would type in a 5, I hit that button, and then I type in 3. And then when you hit enter or you hit your equal sign, you're going to get 125. And this is a very common shortcut for exponents. So when you're typing math, like if you're typing in a discussion, that's the symbol you use to indicate you have an exponent. And that's on the keyboard, it's above the number 6. So it is something on the keyboard. You can even use it in Alex to get exponents. Alex recognizes that as the shortcut. You just hit shift, you hit 6, and then you'll get to that. So most calculators have some sort of button like that. Some calculators have a different button that may look like this, where it says like y to the x. And you use it sort of the same way, where you would type in 5, you'd hit that button, and then you would hit 3. So you're going to want to learn how to use whichever calculator you have. Calculators usually come with directions, and if they don't have directions, you can look online for like the manual to learn how to do exponents. But it's really going to be worth your time to learn how to do that, because that way you don't have to sit here writing out all of the multiplication. So moving to our next example here on the first row, we've got 1/2 to the 5th power. So when we expand that out, that is 1/2 5 times. So if I wrote that out by hand, I'd have 1/2 times 1/2 times 1/2 times 1/2 times 1/2. And that one's kind of even harder to do on your calculator. Some calculators can do fractions, some don't. You know, this is where you really want to be able to use that exponent button. And to do it properly, you have to make sure that you type it in exactly as you see it here with the parentheses around the 1/2. Because to get fractions on most calculators, that's the division symbol. So if I typed in 1/2 and did 1 divided by 2, and then I did my exponent button. So I wish I had some sort of calculator that I could kind of demonstrate here. But if I type in 1 and then I do the division symbol and then 2, my exponent to the 5th, that would put the exponent only on the bottom part, only on the 2. But we want that whole thing as part of the exponent. So you need to make sure you do have parentheses around it to make sure it knows, oh, it's 1/2 that is getting this exponent versus 2 that's getting the exponent. So you have to make sure that with fractions, especially if you're using your division symbol to do fractions, you need to have parentheses around the whole thing. So sometimes, depending on what the numerator is, you'll get the same answer. So if I left off the parentheses in this case, I would get the same answer, but I would not in a different case if the numerator was something other than 1. So when you do 1/2 to the 5th power, now if you're given fractions, you want your answer to be a fraction as well. So if your calculator gives you a decimal value, you need to know how to convert that back to a fraction. So again, you'd have to learn how your calculator does that. But this will give you 1/32. So when your answer is in a fraction with some exponent, you want your final answer to be as a fraction or whole number. You do not want to convert it to decimals. And this is equivalent to if we actually multiplied 1/2 times 1/2 time, did that 5 times. All the ones get multiplied together, which is 1. And then all the 2's get multiplied together. So you have 2 times 2 times 2 times 2 times 2, which gives you 32. Because when you're multiplying fractions, you multiply straight across. So we get 1/32 for our answer here. Now the next one here, we have 0.8 squared. So we have parentheses around decimal values just to make it clear that you don't have it's not a 0 times 8 or something like that. We want to make sure it's clear that it's a decimal here. So we tend to put parentheses around that with exponents as well. And so this is 0.8 times 0.8. If you're given your problem with your exponent and a decimal, then you can leave your answer in a decimal. So you don't have to convert this one to a fraction. You can keep it as a decimal. And so you just have to multiply these, you get 0.64. Now, bottom row here, we've got in parentheses, -6 squared. So this is including the negatives. So this is -6 times -6. And so a negative times a negative is a positive. This is going to give you a positive 36 here when you multiply that. And you can, when you put this in your calculator, you must put parentheses around the -6. If you don't put parentheses around it, then your calculator is assuming that negative is not part of it. So you have to make sure that you have parentheses if that negative is included, because the calculator is going to do exactly what it sees. So without parentheses, you get a different answer than with parentheses. It matters. So the next one, we have another square. We have -10 squared, but there's no parentheses. So the negative is not included here. So we're only squaring the 10, not the negative. So this is a -1 essentially, and then 10 times 10. So 10 times 10 is 100, and this will give us negative 100. And you can test that with your calculator. If you type in exactly as you see, negative 10 squared, and you don't have parentheses, you will get negative 100. If you put parentheses around the negative 10, you'll get positive 100 because now you're including the negative. So it really matters whether you have the parenthesis or not, because it changes the answer and it's changing what it's actually telling you to do. So you really have to pay attention to that. And you have to make sure that you type it in your calculator correctly, because I've seen people do the example where we have the parentheses around the negative 6 squared, but they don't include the parentheses when they put in their calculator, and they get the wrong answer. So it's the calculator is not wrong. Calculator is doing exactly what you told it to do. It's you put it in wrong. You typed it in the calculator incorrectly. So you want to be very careful and make sure that you've got those parentheses where they're needed. And then when they're not needed, don't include them. So last one here, we have negative 5 halves cubed. So this is equal to negative 5 halves times a negative 5 halves times a negative 5 halves. So if you're doing this by hand, that negative could go on the top or it can go in the bottom. It doesn't matter, or you can put it in the middle. It means the same thing. I usually put it with the top. So if I was to do this by hand, I would have negative 5 times negative 5 times negative 5. So when you do that on the calculator, you get negative 125. Denominator, you do 2 times 2 times 2, which gives you 8. So this comes out to negative 125 over 8. And when you do it on your calculator, you want to make sure that your calculator can do fractions. You don't want to give the decimal version. You want to keep it as a fraction. And so you would make sure that you have parentheses around your fraction. And you would type in parenthesis negative 5 divided by 2 parenthesis. You have to have parentheses. Make sure that that exponent is going to the whole thing because of the negative and the fraction. And then you have your exponent of 3. And then if your calculator gives it to you in a decimal, then you need to make sure that you convert that into the fraction equivalent, however your calculator does that. But if you miss parentheses for this one, you could get the wrong answer. So if you didn't put in any parentheses at all, you would get an answer of negative 5/8 if you didn't put in the parentheses, which is a very different answer than the correct answer, which is negative 125 over 8. So really important the way that you're typing these in your calculator, as well as understanding what it is telling you and what is included and what is not included with that exponent.
So I have a question, Professor.
Mm-hmm.
So my calculator is giving me because what you have is an improper fraction. Mine's giving me the simplified version of 15 5/8.
Okay.
Negative 15 and 5/8.
Then you would have to convert that to an improper fraction, because in algebra, we don't work with mixed numbers. So
Okay.
we leave everything as improper fractions. So if your calculator gives it to you as an improper fraction or as a mixed number, you need to either figure out how to tell your calculator change the mode so it doesn't do that, or you need to convert it yourself to the improper form, because we will never be using mixed numbers. It makes the algebra a lot harder.
Got it.
There are other questions? Okay. So that's exponents. So moving on to square roots. So square roots reverse exponents, but specifically only exponents of 2. There are things that you can reverse other exponents, but we don't cover that in this class, essentially. So that would be something you would see in college algebra. Here we're focusing just on square roots. So a square root reverses the process of squaring a number. So if you have some definition that b squared, b times b gives you b squared, then the square root of b squared basically tells you what did you multiply, what was the base. And so that would give you b. So it gives you the thing underneath the exponent, essentially. So the symbol that we use, what we typically call a square root sign, is actually called a radical sign. That is its official name. And it has a line up the top, and that line only covers what is inside or under the radical. So that line on top, you need to pay attention to where that stops, because it matters. If you see something like 5 plus 3 here with the whole thing, that is different than if you see it just with the 5 and then the plus 3 is outside there. So it matters how long this line is going. So you have to pay attention, because anything that's directly under the line is part of the square root. If it's not underneath, it's not part of it. And so that affects the order of operations, because we always do what's inside a square root before we take the square root. And so it would change whether you're doing 5 plus 3 first, or whether you're taking the square root of 5 first and then adding 3. So the order matters. You really have to pay attention to how far that line is going across, because that is telling you what's inside or underneath it and what is not. So you have to pay attention when you're in Alex and or in Connect Math and you're typing your answers. You also need to pay attention to when you're writing your stuff on paper, that you're writing it correctly, because I often see students put the line in too far on paper, and then they do the wrong problem, because now they're not doing the same problem that they were given. So we can take square roots of basically any positive number, but most of them are going to give you decimals, because most of them come out as irrational numbers, and then you end up having to round. The ones that we usually want to take square roots of that give us a whole number, because if it gives you a decimal, we don't want to actually do it, because it's just actually worse. It's not simple. It's better to leave it inside the square root than to actually round it. So the ones that we actually do take the square root of that give us a whole number, those are called perfect squares. And the one thing to know is that if you try to take a square root of a negative number, you're going to get an error on your calculator, because your result is not a real number. So, and that's because the square root is telling you what squared gives you this other thing. And if you square a negative, you always get a positive. So if you're taking the square root of a negative, there's nothing squared that gives you a negative. So there's no real number that does that. So you cannot take a square root of a negative, because there is no, going back to the exponents, there is no back and forth. There's any negative number that you square is going to give you a positive and never gives you a negative. So it's worth memorizing the perfect squares up through 10. I would actually memorize up through 13. I have them memorized up to 13, and I know 15 squared. I don't know 14 squared because I rarely need it, but the other ones I've seen often enough that I've ended up memorizing them. So it's worth memorizing what these squares are, because then that means you can also go the other way, and you know when you can take square roots of these and then you can take the square root, because they are basically undoing each other. So 0 squared gives you 0. So the square root of 0 is 0. Goes the other way around. 1 squared is 1. Square root of 1 is 1. Once you start getting into different numbers, it makes a little bit more sense. So 2 squared is equal to 4. So when you take the square root of 4, you get 2. You get the number underneath the exponent because it's undoing that exponent. So 3 squared is 9. So the square root of 9 gives you 3. It gives you the base. It gives you the number underneath the exponent. And your calculator will do all of these. So the way, every calculator is different. Some calculators have a button for the square root symbol. Mine is, I don't have a direct button. I have to use second to get to it, and it's actually above my exponent button because it makes sense because they go back and forth. They're inverses here. But it's going to be worth knowing how to take the square root, how to do that on your calculator. But if you have them memorized, you can do it faster than typing it in your calculator, because if it's just if you have it memorized, you can do it in less than a second. While with your calculator, you're sitting here typing it in, it will take longer. So it is worth memorizing these. So we're going to simplify the square roots. So simplify, again, it means we're basically going to find what these are equal to, what the number is. These are all square roots. So we're going to do these, basically take the square root. So first one we have is the square root of 64. So if you're trying to do this mentally, if you don't have them memorized, you ask yourself, what number squared gives me 64? 8 squared gives me 64. So the square root of 64 gives me 8. So the answer here is 8. And if you put in your calculator, that's what you would get. Square root of 144. So you're saying what squared is 144? So 12 squared is 144. So the square root of 144 is 12. Again, you can just type that in your calculator. Fractions are a little trickier. You can still do these mentally, but it's a little harder because doing mental math with fractions is not necessarily easy. So this is basically saying what squared gives me 1/9. And so you're kind of looking at what squared gives me 1, what squared gives me 9. So 1 squared is 1 and 3 squared is 9. So if you're reversing the other way, that gives you 1/3. And this is where you might want to use your calculator. So again, when you're doing the square root, you want to make sure that you have the 1/9 in parentheses here, just to make sure that when you're taking the square root, you're doing the square root of the whole thing. So we don't normally put it in parentheses with the square root symbol because it's already kind of grouped together. But if you were typing this into your calculator, so I've got a button that says square root, and then I would hit a parenthesis and I would do 1 divided by 9, and then I'd have to close my parenthesis. If I don't do that, it will only take the square root of 1. And then it would divide that answer by 9. And that would give you the wrong answer. So you want to make sure that you have parentheses around your fractions here to make sure you're doing it correctly. And then if your calculator gives it to you as a decimal, then you need to convert it back to a fraction, because if you're given something with a fraction, we don't want our answer to be a decimal. We want it to be a whole number or a fraction. So we'd have to make it a fraction. So next row, we've got the square root of 49 over 100. So you can do the same sort of thing that I did with the 1/9. You say, what squared gives me 49 and what squared gives me 100, and then you undo them. So 7 squared is 49. So the square root of 49 is 7. 10 squared gives you 100. So the square root of 100 is 10. So the nice thing about these square roots with fractions is that you can do the top and the bottom of the fraction separately. And you don't have to think about what fraction multiplied by itself gives me 49 over 100. You can do the whole number parts, and it does make it a bit easier to work with. So that answer would be 7 over 10. Now, next one, I have negative square root of 25. So the negative is outside the square root. So this is -1 times the square root of 25. So these are separate. So you take the square root of 25. So 5 squared gives me 25. So the square root of 25 is 5. So this would be -1 times 5. And so we get an answer of -5. So if your negative is in front of the square root, then you're going to get a negative answer there. The last one I have here, we have a square root with a -81. So here the negative is inside. So you're asking yourself, what two numbers when multiplied together gets me a -81? Now, two numbers multiplied together, in order to get a negative, you have to have a positive times a negative. But if we're doing a positive times a negative, we are not squaring anymore because they need to be the same thing. They have to have the same sign. So it's impossible to multiply two things together and get a negative, because you're either going to have a positive times a positive, which gives you positive, or a negative times a negative, which gives you positive. So you can't get a negative. There is no way to get a -81 when you're squaring. So when you try to take the square root of -81, there's no answer that will do that. So we say that this is not a real number. When you get to college algebra, you will learn about imaginary numbers. And those are the things that were created in order to do square roots like this. But you guys are not in that class. So in this class, we just say it's not a real number. It's not something, there is no number that will make that work. And if you try to do that on your calculator, my calculator says domain error. And that just means the domain is like your input. So it's saying there's an error in my input here. I can't do this. So most calculators will give you an error. And so you cannot do it if the negative is inside the square root. So it's okay to have the negative outside, but it can't be inside. And I don't have an example here of decimals, but you can take square roots of decimal numbers as well.
So would this be an example of undefined then?
No. Undefined is different from not a real number. Undefined is used when we're dividing by 0. It means that we do not have a definition for this operation. So when we divide by 0, dividing is defined as multiplying by the reciprocal. So dividing by 0 is multiplied by 1/0. And there is nothing that can like do that. Like it's like the same, it kind of violates our definitions here. So that's where we say undefined, because it doesn't match with our definition of division. Our definition of division, which is defined as multiplication, is unable to do that. So we say undefined. Our definition in this case does work. It just doesn't give us a real number. So there's nothing wrong with the actual definition. We have a definition here. It's just that it's not a real number. It gives us an imaginary number. So it's different from undefined.
I think I have it. Okay.
Are there other questions? Okay, so that was my last example here. So the key is you really need to pay attention to the symbols, where you have parentheses, where you don't have parentheses, where the negatives are, where are they not. You know, be able to use your calculator and make sure you're typing things into your calculator. I recommend memorizing those perfect squares so that you can do those quickly, and then you can take the square root quickly as well, and you don't have to sit here fiddling with your calculator.